Hello, welcome to the video on harmonic analysis using discrete Fourier transform. In this part 1, we are going to simulate the nonlinear load. I'm Ganesh from Kekewag Institute of Engineering Education and Research, Nashik, welcomes you in this video. This is the problem statement of simulation of nonlinear load. Prepare following simulation in MATLAB Simulink and observe the waveform of bus voltage and current for the simulation time of 0.1 second. Take the samples of the current of a phase A in the workspace and name it as IA, and take the 128 samples per cycle. Here there is a source of the sinusoidal supply. It is a 3-phase 440 volt 50 Hz AC supply whose short circuit level is the 10 MVA and X by R ratio is a 10. Here we are going to, we need to introduce a VI measurement block, that is voltage and current measurement, and then nonlinear load, which is the 3-phase diode bridge rectifier. The output of this diode bridge rectifier is connected to the resistance of 10 ohm and inductance of 0.1 Henry. We have to simulate this circuit in the MATLAB Simulink such that it will such that from this VI measurement block we will get the current IA with 128 samples per cycle, and which must be stored in the workspace. This is our problem statement. So let's begin how to simulate this diagram. Okay, so we are on the window of MATLAB. Here, click on the Simulink. Open the blank Simulink model. Okay, it is generating a model. Okay, so on this window we are going to simulate our diagram. So first I will capture that diagram from I will post that diagram here so that it is I can take the reference of that diagram while drawing. So already I have stored that file with a JPG as a single line diagram on the command window. So let me reduce the size of this file. So any image you can insert in the MATLAB Simulink so that by that single line diagram or any reference diagram you can able to easily draw the another diagram. So this is my single line diagram which is to be prepared in the simulation, which is to be prepared in the MATLAB. So let me address its okay. So I want to prepare this. So first I need the 3-phase AC supply. So for a 3-phase AC supply, I will search for 3-phase AC source. Solver configuration. Okay, solver configuration. This solver configuration must be attached to this neutral point, and here we have to give the electrical reference. So electrical reference. So I'm getting this is electrical reference. So electrical reference is connected to this neutral. Now I need a 3-phase VI measurement block. Okay, so VI, voltage and current sensors I need, voltage and current sensors or current and voltage sensors. You can see here it is a current and voltage sensor. So this is a single line diagram. Actually there is a 3-phase output. This if you double click on this block, and if you want the this block has expanded 3-phase port, then it will give the expanded port as a phase A, phase B and phase C. Similarly you can expand here also. So here also you can expanded 3-phase port as a phase, B phase, C phase, A1 B1 C1, A2 B2 C2. But I don't need I want a composite port that is just like a single line diagram. I can prepare this, so I'm preparing the composite port. Now come to this AC voltage source. In this AC voltage source we have to keep this RMS voltage. So this rating is equal to 400 volt. So I'm keeping the phase to phase voltage is 400 volt. There is no phase shift. Frequency I'm going to pick the 50 hertz. I'm going to keep the short circuit level as a 10 MVA. So 10 e raised to 6. 10 MVA means 10 e raised to 6. Here the unit is VA. You can express the unit in terms of watt, gigawatt, megawatt, kilowatt. Okay, so I need this AV, that is ampere voltage into current. So that is VA rating. So 10 raised to 6, and I am keeping the X by R ratio is to the 15. So this is about the block parameter of the voltage source. Now this voltage source is connected to the my voltage and current measurement block. From this two button we'll get output. So to this two I want to connect the three phase bridge rectifier. So I'm typing here three phase, or simply type bridge rectifier. Okay, so I need three phase bridge rectifier, or you can type here, okay, rectifier three phase. So you will get this rectifier three phase, where you can give this input as expanded, or if you want to give the different phases, then, or if you want to give as a single line diagram, then you can make it a composite. Voltage drop, forward voltage is 0.8 volt. On state resistance I am keeping as it is 0.001, and off conductance is 1 e raised to minus 5. So I will connect this two number here. Now outside to this I have to collect the resistors and inductors. So I will type the resistor. Okay, so rotate by control R. Control R, if you do the control R, it will rotate. So this load resistance is connected here. Then I need inductor, because my load type is RL. So again I can connect this RL load here, this as a line, and this inductance terminal is connected to the negative of the bridge rectifier. Okay, so now inductor value I'm going to address as a 0.1 Henry. Inductor value I'm going to address as a 0.1 Henry, and resistance value I'm going to address as the 10 ohm. So resistance is equal to 10 ohm, you can see, and the inductance value is adjusted to 0.1 Henry. Now I need this voltage and current measurement on the scope. But this model is created in the physical simulation. So to get the physical quantity output into the simulation, here we need a PS Simulink converter. Okay, PS Simulink converter. This PS Simulink converter converts the physical system into Simulink system. So what is the need of this? We want the waveform output as a simulation output. So voltage block is connected here. Similarly, I will copy this, or you can take another one, PS Simulink converter. Okay, PS Simulink converter, and I will place this PS Simulink converter here, and here I will connect the current measurement. So current measurement is connected here. So now after adding this voltage measurement block, here we three phase output is available, that is VA, VB and VC. So double click on this voltage measurement block. I want this voltage measurement phase to ground voltage, so make it as a phase to ground voltage, that it will measure the phase voltage. Now here I will take a demux, because okay, so first I will take a scope. Directly I will show that result on the scope. Okay, scope, and I will connect this is to the scope. Similarly, this quantity, or you can create a two axis into this. Double click on this, go to in the setting of Simulink, go to the setting of scope, click here, number of input ports are 2, and create the vertical layout with 2 row and 1 column. Okay, so here you can see the 2 row and 1 column. Sorry, here it is 2 is not applied. Okay, so 2 apply. Okay, so there are two scopes are created. two graphs are going to create. In one voltage is displayed and in another current is displayed. Now you keep this simulation timing is to the 0.1 second and run the simulation. Okay. So in this window you can observe the voltage and current waveform. So upper one is the current voltage waveform and lower one is the current waveform. If you want to give the names to this waveform, so you can type here voltage and here you can type current, or rather you can type here phase voltage, and this is phase current or line current, anything. So I will type here phase current and again run the simulation. This name you can observe here, phase voltage and phase current. If you want to this make this graph with the white color, go in the setting, display. If you want it this into white color, sorry, right click on this graph, go in the style. Okay, in style you can adjust this figure color with white, axis color with black. Okay, this color is also black and axis color is to white. So this is white, this is white, axis color is white. Okay, if you want more thickness of this, you can increase the thickness. So I'll increase this thickness to the 2. So you can observe the RYB waveform you are getting there. Suppose you want the first color with red. Okay, then apply. So first color is red, second one is the blue, and third one is you are getting this as output. Similarly, you can increase the thickness here also. Here also you can change the style. You can increase this thickness to 2 and start color with the red. Apply. Okay, so R phase is displayed. Now I want to display only the R phase result or A phase result. So here there are three signals. I want to convert these three signals. I want only one signal as output. So I will connect a demux block. Take a demux block, double click on that, make the number of output ports is equal to 3. So increase this size. I will connect this block here. Next, I will take another block from here. I will connect this to here. This is connected here and this is connected here. Now this phase voltage name, okay, you can delete from here, and phase current name also I will delete from here. Okay, phase voltage, phase current names are delete. Here I will give the name VA, A phase voltage, which is in terms of volts, and here it is IA phase current, which is in terms of ampere. Now again run the simulation and observe here you are getting only R phase voltage, that is A phase voltage and A phase current. A phase voltage and A phase current. So here you can observe the current is totally non-linear in nature. The current waveform is totally non-linear in nature. So this data I want to store in the workspace. The current data I want to store in the workspace. So I will take a block of two workspace. I will connect this two workspace block to the current IA, and here I will give this variable name as IA. Okay, and I want to store this result as a structure with time or array. You can store this result with structure with time or array. As I need this data for harmonic analysis, I will store this result with the array and I will give the sampling time. I need the sampling time as my one cycle is of 50 hertz. So time one cycle is correspond to 1 upon 50 seconds, and in this 1 upon 50 seconds I need 128 samples. So in denominator 1 upon 50 by 128, this is my sampling frequency, because I need 128 samples per cycle, and one cycle is corresponds to 0.02. Rather you can do this as like this: one cycle is 1 upon 50. Okay, 1 upon 50, again it is divided by 128 samples per cycle. So this is your sampling frequency. Apply. Okay, now this data will be stored with the IA, but for from here I will change go in this auto, which is at the right hand corner, solver. Go in the solver setting. The setting is required for exporting the data import export, and remove this single simulation output block from here. Okay, so untick this single simulation output, untick this, apply. Okay, now you can see here name is not out.ia, now it is only ia. Now I will run this simulation once again. Come to the MATLAB window. Okay, I will create here default layout. So you can workspace, you can see there is IA data is stored. So here you will observe this IA value of IA is stored, or you can type here directly IA, it will display the value of IA with all samples. So this is the current. So you understand how to simulate this how to simulate the single line diagram. Later on you can save this diagram. Okay, so for source we have created a, we have taken the voltage source 3-phase. Here we have taken the current and voltage measurement sensor. Here rectifier bridge, resistor, inductor. Here demux. Here one more demux. Here's PS simulation converter. Here we have connected a scope, and here we have connected the workspace. Okay, so you prepare this file according to given en, therefore roll number into 10 and roll number divided by 10, so that for a different for one students the result will be different.